Mass versus weight. Understanding the difference between intrinsic properties and gravitational force. These two concepts are often confused, but they represent fundamentally different physical quantities. Mass tells us about the amount of matter in an object, while weight tells us about the force of gravity acting on that object. Let's start with mass. Mass is the amount of matter in an object. Think of it as how much stuff makes up that object. It's an intrinsic property, meaning it belongs to the object itself and never changes. Whether you're on Earth, the Moon, or floating in deep space, the mass of an object remains exactly the same. It's a fundamental characteristic of matter. To illustrate this, consider a person with a mass of 70 kilograms. On Earth, their mass is 70 kilograms. If they travel to the Moon, their mass is still 70 kilograms. Even in the vacuum of space, far from any gravitational field, their mass remains 70 kilograms. The amount of matter in their body hasn't changed, regardless of location. Now let's talk about weight. Weight is completely different from mass. Weight is the gravitational force acting on an object. It's the pull that gravity exerts on the mass. Unlike mass, weight is not intrinsic. It changes depending on where you are and how strong the gravitational field is at that location. Weight depends on both the mass of the object and the strength of gravity. Using the same 70-kilogram person, let's see how weight changes. On Earth, where gravity is 9.8 meters per second squared, their weight is 686 newtons. On the Moon, where gravity is much weaker at 1.6 meters per second squared, their weight drops to just 114 newtons. In space, with virtually no gravity, their weight becomes 0 newtons. Same person, same mass, but drastically different weights. The relationship between weight and mass is expressed by a simple formula. Weight equals mass times gravity. W equals m times g, where W represents weight measured in newtons, m represents mass measured in kilograms, and g represents gravitational acceleration measured in meters per second squared. This equation shows us that weight is directly proportional to both mass and the strength of gravity. Let's summarize the key differences. Mass is the amount of matter and is always constant, measured in kilograms, and is a scalar quantity with only magnitude. Weight, on the other hand, is the gravitational force that changes with gravity, measured in newtons, and is a vector quantity with both magnitude and direction. Understanding these distinctions is crucial for properly applying Newton's laws of motion. Here's an easy way to remember the difference. Mass is what you are. It's the fundamental amount of matter that makes you who you are. Weight is how gravity pulls you. It's the force exerted on your mass by whatever gravitational field you're in. Mass is intrinsic, an inherent property of matter. Weight is gravitational, dependent on external forces. Keep this distinction clear, and you'll have a solid foundation for understanding mechanics.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.